said. Thank you again for joining the webinar. Today we're going to focus on antFarm data movement solution for migrating your workloads from on-premise to the cloud. For all of you that haven't been with us so far, we have been running this webinar series for a couple of months now. We started off with different migration strategies, deep dive technical migration webinars where we were discussing of how to migrate from different technologies like IBM Netezza, Microsoft SQL Server on-prem version, of course, and Oracle Exadata. We continued with our asset called Data Merlin for data warehouse automation tool. And as said, we're going to finish off with antFarm data movement tool. So for all of you that haven't been with us so far, feel free to visit our webpage where you can find all the recordings available. So if you have emphasis to watch what we have been working so far, please visit the website and to download or watch all the videos online. But today I have two co-hosts with me, Jan and Miha. Miha is our antFarm product owner, senior data warehouse developer and lead engineer. And Jan, our antFarm developer, both being with us for a long time already. Yeah, all the questions you can put in the chat box or under the question box. We'll answer all the questions at the end of the series. I'm just gonna switch off my camera just to avoid any issues down the road. Let's start. A few words about Insight, since not all of you have been with us so far. Insight is a company 11 years old. We have been on the market for 11 years, and we've been focusing mainly on end-to-end analytics solutions. So we don't really do any other development except assets that we have been presenting so far, focusing or helping us to accelerate migrations, migration projects, and of course data warehouse modernizations. So we have lots of experiences, more than 15 years, a lot of consultants with more than 20 years of experiences. And so far, we have done around 150 end-to-end data analytics projects. I would say that what makes us different is the fact that we've been actually combining technical and business knowledge from various industries with emphasis on the ones that you can see on the screen. So banking, insurance, telco, retail, and energy. And we've been working with the latest technologies, either on-premise, on cloud, with, of course, last 3 years or last 4 years focusing on cloud-first strategy, helping clients to either move their on-premise data warehouses to the cloud in form of lift and shift or modernization strategy, and building cloud-first data warehouse solutions. We have mentoring approach, meaning we would like to move as much knowledge as we can to the customers so that they can in some ways take over development or at least maintenance of their data warehouse solutions. So we do a lot of advisory and consulting, as mentioned, end-to-end data management projects, performance management. We do managed services for small and mid-sized companies, and lately quite a lot of data science and AI services. So when it comes to, let's say, data warehouse modernization or data warehouse migration projects, we have to admit that this is not really a trivial task, and each and every migration project is, of course, different. And that's why we help companies understand how to start, where should they start, what needs to be discussed, so what are going to be the use cases, how we're going to set up the priorities, how we're going to set up our internal teams, how we're going to set internal external team project management, what knowledge is needed for modern cloud solutions, and of course, at the end, very important, what's going to be the potential costs and benefit. And this is where we basically provide the different types of offering, helping clients to tackle different business and technical problems. We've been working with Snowflake for 4 or 5 years now already. Been very successful, not only because of the internal knowledge, but because of the really good cloud platform, Snowflake Data Cloud. And just yesterday, we've been awarded as best partner of the innovation partner of the year in EMEA region, which we are really proud of. And now, without further ado, I would like to pass the microphone to Miha, who will do the presentation of antFarm solution.
Hi, as Clement was saying before, that we are long-term warehouse developers, and we are working hard on innovating these warehouses. The world is changing a lot. The warehouses of yesterday are different today. They're growing in sizes and in uses. So if we break down the things that warehouses support, they have multiple data sources, different data sources. These multiple data sources need to be unified to get the most out of them, to get the organization in the data warehouse as straightforward as possible, till the users can get the most out of them. This is the priority normally for warehouses, that users are the ones that use the warehouse, and users are the ones that dictate where the warehouse is going. But our job in this course, in this process, normally is to get the data in the most standardized way through from the sources to the destinations where users get them. So in this process, we normally focus on the thing that clients normally have the most problems with, that is that the standardization of the processing. Because when every part of every source has a different strategy to load the data to the warehouse, this means that it is very hard to manage it, and very hard to support, very hard to get the loads every day into the warehouse. So the main thing is to limit the special cases to the minimum, and to get those special cases standardized as much as possible, so that we can have as little different loading processes as possible. So and in this case, we are moving more and more towards the automation of those repetitive tasks. As Clement says, one tool we developed is Data Marlin, that automates the data warehousing. But on the other side of the spectrum, we have a different part of the ecosystem. Clement, you can move on to the next slide. You have we have a different tool, that's antFarm, that is a low-level tool, the low-level framework for moving the data. In the between of those two tools, we have two different solutions that are also very important for the data warehousing. That is Codify, that can facilitate data augmentation. That means that if you have data from the source that needs to be normalized for the different sources, so that the data is also data from one source is connected to the other source, or that you need to enter additional data on the daily basis, so that your presentations from the data warehouse are as human as possible. This is what Codify should facilitate for you. And then it's Parser. That's a tool that can translate different SQL dialects, and this is targeted mostly to the people that want to migrate a data warehouse from one to another. As Clement says, that today's presentation is not about the whole ecosystem, but the antFarm itself. And what antFarm can show us here is that it can be used for different sources with the standardized workflows, so that you can get the most out of your sources to the warehouse itself. Next slide, please. So when we are moving data with antFarm, we have multiple options, as it is in life. Most of the first priority of antFarm was to move data as quick as possible. That means that we have to get something out of the source in a timely manner, so that the daily processing of the data warehouse is as quick as possible, and the users get data as timely as possible, so that it can be used at the right time. And that means that we have a parallel execution, which facilitates speed. And that's not speed out of the source, because we are really dependent on drivers that are available for that source, but we are focusing more on efficiency. That means that when we get data, we can slice each table to something we call partitions. They're not similar partitions as we have in database, but they're partitioning the data itself, so that it can be exported out of the source in a parallel manner. That means that we can have multiple requests to the source, and these multiple requests will be served in parallel and get the most out of the speed and functionality of the database. This is then incorporated in a procedure inside antFarm that does this parallel processing, that takes all those partitions that we set it to run, and unloads them in batches. That means that we can say, okay, export 60 parallel partitions at a time, and then when if we have 1,200 partitions, we have, when one is finished, we'll take 61 and 62 and 63, and this makes the process as efficient as possible. On the other hand, you can have sources that need parallel execution, that need to be smart. That means that we have to read the source and get all the data that are available at that time. That means that if you have a batch of files on a source that are not named the same every day, or they are not the same number every day, we have a functionality that can read that folder and get all the files in the folder, and then process them one by one or in parallel. That's also an option. The execution in both these cases is configurable, and it's configurable in the database. We'll get to that later. And all these executions we call workflows. That means that we can set step 1, step 2, step 3, and this workflows then execute on every instance that we have, or we have a partition, or do we have a file and a source. Next slide, please. All these configurable workflows need to get the settings, where the sources are, what the parameters are, and we have named connection strings for database and for file systems. That means that you can operate the workflows we are talking about in the same manner that you're operating at them in the case of some user interface functional thing like data stage or SSIS. That means that you can have, okay, I'll take this source and I'll take it, I take data from that source in a special in a way through the workflow. So that means that these workflows are all parameterized, and we can have, okay, from this source we take this data and put it to this table. This is all parameters and can be expanded to all the tables. As I said before, the functionality that we have for each disk expansion is put into a queue, and we're processing this queue in batches, so that 50, 60, 20, depending on the source, we can execute these 50, 60, or 20 parallel executions and move on to the next one when one is finished. In a serial execution, we are using a stream paradigm. That means that the file that we find on the source folder, this file goes through a number of tasks that are done on it, and the connecting thing through all this functionality is a stream. That means that data is read from the source and then pushed to the next functionality as we need. Next slide, please. The configuration we were talking about, the serial and the parallel, they're both inside JSON packages. They're more or less standardized so that we can put those JSONs to your database, to the functionality inside the database, and when antFarm runs, it will read those configurations at the start and then execute the so-called programs inside it, so that we can have all the programs, all the workflows, all the functionality that are needed to export the data or to process the data. We have them in a centralized place, and this is what you will see at the end of this presentation, that it's very functional, so that we can have this centralized configuration that is used on all the for all the instances, as we can have multiple instances of antFarm if it's needed. That means that we can dedicate special instances for special sources, or we can have a production machine, a test machine, or we can have multiple production machines, multiple instances of this antFarm, so that we can and it can use the same configuration or different configuration. This is something that we can play with when we work with your configuration and your needs. Next slide, please. The data is moved with the standard API and databases. That means that the antFarm is in its basic framework written in Python, and it utilizes a DB API 2.0 from Python that is standardized and used in most of the drivers we can use. If you get a source that is not already supported inside an antFarm, we can easily adopt the same functionality as you see on any source that we'll be presenting today to a different source if it supports these standards. So don't worry, we are supporting the big ones, the databases that are normally used. But if we have something, as we call in the last, if I recall properly, in the last case, it was Informix. A client says, "Can you support Informix?" I said, "Okay, we can support Informix if there's a Python driver, and if it supports this DB API 2.0, we're good to go." Because The next thing and the most important thing that we are carrying through our experience to the antFarm is that the export is defined with SQL. That means that you can define what data you want to get from the source by writing an SQL, putting it into a table, defining the destination table inside that table, destination table for the data, and we can run with this SQL and put this SQL to the intermediate buffer in CSV format. And if the destination database can read that CSV format, antFarm can support you in your needs. Well, this CSV format that antFarm can produce are normally for data warehousing purposes supported for batch imports, so that we combine this the standard APIs that Python provided and the batch import to the data warehousing solutions that we were seeing on the market, and combined both of them into an antFarm solution. That means that exporting data with Python or directly out of the database, that will be something that we'll be talking about later, and producing the CSV that will be batch imported to the warehouse. That means that we're utilizing and automating this process into something that users can readily use in a standardized, simple manner. That means that you provide the SQL, you provide the destination table. If batch importing is, if your data warehouse is capable of batch importing, we can do the import to your destination. After that, because we can connect to that database, and if it's SQL capable, we can run any query, procedure, or something on the destination data, so that that your data warehousing workflow can continue out of the exporting phase that antFarm is facilitating for you. Next slide, please. So in this presentation, mostly what I was talking about is this parallel execution. This is something that we can build the most out of with antFarm, because this parallel execution and the queuing paradigm makes us as efficient as possible. That means that we get a bunch of SQL statements into a table. In this bunch of SQL statements get put into tasks that antFarm will work with. antFarm name comes out of this simple task, simple organism, simple functionality that runs whatever you give it. In the antFarm world, it's pheromones that are put out there. In antFarm data warehousing solution, as we're talking about today, this is a task. A task is populated with the information that is needed, with the sugars that ant will move to its antFarm or to its ant hill, and this sugar will be processed in an efficient way. They will run one after another. In our case, even in parallel. That means that all the data that you want to move from one side to another will be moved as efficient as possible. We can be the fastest solution you will see, but we are dependent on the efficiency we can get out of the system. So we'll talk later about efficiency and scaling inside antFarm with our deployment with our deployment procedure. In our experience, this antFarm paradigm, this parallel execution paradigm, was the best we can get, because we're running on a Python framework directly on the hardware, and that means that we can facilitate the hardware as much as possible. If we can't get data fast enough out of the source, we can move to multiple parallel executors, and these multiple parallel executors can also get much more out of the source. And that means that these workers, as we call them, these workers as they are called also in the ant world, they will move the sugars, move the data out of the source to the destination as fast as possible, so that they are not exposed to the world too much. So these these tasks, as we're calling, that get put to the workers, these tasks are also parameterized. The parameters for the workflows that can be adjusted for every need. But our experience, as I said, was that when these tasks can be pushed to different cores on the machine, the speed can be increased, and it is scalable. The limits that we normally see are on the source side. That means that the source can't get the data out of the database as fast as we would like to be, or the network, because we populate the network to the top, and no new data can write through that, can be transferred through that. And all this stuff can be tested in a pre-production environment where we're preparing the transfer, the functionality of antFarm itself, and we can tweak things so that we can get the most out of your hardware. Because, as I said in the beginning, it's getting the data to the warehouse in a timely manner so that users can get it at the right time. That means that users can see the data, can explore the data, and also know if the data was transferred in something uh, that transferred in its whole, its entirety, so that we cannot get missing referential constraint from transferring the data. Every step in this workflow is predefined with the number of workers. That means that we can export the data out of the source with 60 workers, so that we can get data out of the source as fast as possible. Then after this export is finished, we need to transfer this data to another location, an S3 or a stage on a Snowflake. And this can be done with smaller or bigger number of workers, depends on what our environment is capable of. And then at the end, there's processing on the destination, and this can also be the number of workers on that side can also be adjusted so that we don't overwhelm the destination, and the data can be transferred to the destination table as fast as possible. And also after that, each table can get a call to a different procedure, to a procedure where the procedure gets the information this table is ended, so that in this the workflow we're calling it is ended on the processing on the destination warehouse, so that we can get as fast processing as possible. These steps in the workflow are standardized, so that we can have a different number of steps in each workflow. That means that in some cases, in the standardization I was mentioning at the beginning, in some cases we need to export the data out of the the source database, and then putting it to Snowflake stage. And after that, we need to put it to a table. In a different case, we get the exported CSV or something that is already lying on the on some S3 bucket or Azure container or local folder. We can take that that file and put it to the stage and directly then importing to the table. So this each step is standardized, but the workflow can be adjusted to the need of the execution. Yeah, next step, next slide, please. Yeah, yeah. This is the thing that I was talking about until now is the bread and butter of antFarm. The most of the data warehousing solutions will need a fast and efficient transfer of data from the source to the destination. But in some cases, the data is produced by some other system, not a database. Maybe people define some files, put them on some folders, or they're put by some IoT device that produces a file every minute, every second, every hour, and we never know how much files we'll get. But the data inside is standardized so that we can make something out of it. So we can transform it into something else. And in this case, antFarm got another leg in this in this fight, and it it has an implementation for serial execution so that we can read the source folder, so source blob or something, and these blob, the insides of this blob are then processed and moved to the destination table. The workflow itself can be a little bit different. The functionality is different. We get a stream, we can transform the stream, we can compress it and put it to the stage. But and after that, if it's in the stage, it can be a JSON file, not the CSV file that we are talking about. JSON file is less efficient because it has all those column names inside it. And this JSON file then can be transformed on the destination. We can compress it on the antFarm side, but that's as much as we can do. We can process it in some manner, but that would be out of the standardization paradigm I was talking about. But on the other hand, if we can compress it, put it to a stage, for example, on a snowflake, then Snowflake has that fine and great JSON parser, and we can read the JSONs out of those zipped files and put it into a tabular form in some sort with additional views or some other functionality on that type of database. So if a database, if your destination warehouse has some sort of functionality that can work on files, and that is something that data lakes employ in a big manner today, then we can also facilitate that part. We can take some files from different sources and put it to one destination that you want it. Maybe it's multiple folders, but it's still some organized, not on different sources, on different countries and different on different platforms. So we take these sources, we read them, we get all the blobs that are inside it or files that are inside it, and put them into a compressed manner and put it there. If destination warehouse doesn't support compressing, we will not compress it, but just put the files there in a place where your data lake or data warehouse can use them for processing after that. So this a string of processors that we are talking about. This is just programmatic functionality that gets fed an input stream, and the output stream comes out, and then this output stream is then pushed into another input stream to another processor, so we can string a lot of them together. At the end, we will see the final processing data on the data in the data lake or inside some data warehouse, and additionally, there's a control flow we can work with to get the best out into logging. And it's something that I forgot to mention all this all this time in the functionality of antFarm. It's also a logging functionality. Most of the time, it's inside workflows for those parallel workers. At the end of a workflow, we can say, okay, did an error occur or didn't occur, and accordingly, we can log the information to the database. In its base functionality of antFarm, we have a log on the instance itself. All the things that are run are also logged into a file. so that some admin can open a file and see what came out. But also we have some functionality inside workflows that can log into a different table. We are, as I said, as we said, we are facilitating queues inside for workers, and these queues are a mix of a queue and a log, so that every element in the queue is checked, is finished, and we can see where in the process we are, and we will see also what we are doing. All these objects in the database reside in something that we call a Queen API, because it's a paradigm of an antFarm. This Queen facilitates all the workflows, all the settings that antFarm instance is using, and it can run out of it and also put the information back, so that you can see what was done, what wasn't done, and where the errors occurred. So next slide, please. Yeah, as I said, we are supporting different sources. We have a lot of databases that support this DB 2.0 API in Python. These sources are the best, the biggest databases that we can use, and also some obscure ones. But on the other hand, we can also provide some support for some REST sources on a similar manner, though they were done by us, transforming a REST into this DB API 2.0 from Python, so that they can be plugged in the same manner to the antFarm as a normal database. We don't support writing on this REST, but for now, but it's something that we can read data from, so that clients can get that data from different sources like Salesforce or Minimax or SurveyMonkey or something like that. This is this Mailchimp version. These are also things that we can adjust antFarm for. Okay, next slide, please. As I said, all the big destinations are supported with antFarm. We mostly worked with Snowflake. Now we have some clients that still use Netezza in a different manner. That they are happy with that data warehousing solution, and antFarm also is just plugged in to the Netezza box via NFS share, and this NFS share facilitates the export and the import of data for the Netezza data warehouse solution. We are working with one client right now for the Synapse support. Basically, Synapse is just a different way of using a data warehouse, but the solution for our CSV that we prepare is also adjustable to the Synapse. But in this case, in case of Synapse, there's no NFS to share with, because it's cloud solution. It's also for Snowflake. And in all those cases, we were working really hard to get support for the cloud solutions for file deposits, and we have support for S3 and Azure. And in both those cases, we can export files from source system and put it to the Azure or to the S3, and if Snowflake or Synapse can read both those sources, the files can be imported into destination tables. So this is something you can also dream your solutions into it, because we can produce, in this case, CSVs, and these CSVs can be put in S3 or Azure, and any solution that you you would have after that is also something that we can facilitate for you. If it has a way to call another functionality, then that would use these files that are on S3 or Azure, then also antFarm can help you. And with this, I will move my baton to my colleague Jan, that will provide you with more information about deployments.
Thank you. Hello from my side as well. Let me see. Okay, I will start with describing how usually deployment looks like when we meet with a client, and what we want for antFarm to work optimally. I don't know if Micha mentioned, but Python, but antFarm is a Python framework which is using and working with Python 3.6 or higher. We preferably want to put and set up antFarm on a Linux instance, but that is necessarily not a rule, since it's also capable of running on Windows, but in a smaller capacity. We are actually leaning during the deployment of antFarm to use minimal additional models. At the moment, the only required models are PyCrypt DOM for encrypting files and SQL parse. With, of course, with additions of models that are required for sources and for our sources and destinations. For sources and destinations, we also already have prepared, we have a script prepared that sets up the environment on its own. And after we set up the antFarm on the instance, we also need to prepare a Queen API that Micha already mentioned before. That is that is set up by creating some objects on a couple of objects on the database. And after this Queen API is set up, all we need to do is connect to the sources and to the database and to the destination. Usually these connections are written on the database where we rely on the security protocols of the database for, of course, for the security of data that are written in these connection strings. Or there is also a possibility to store these connection files on the instance itself, where we ensure to encrypt those files. As Micha mentioned, antFarm is very flexible when we are talking about the environments on which it will run. We can set it up on a local machine, or for example, on the iOS Linux instance. And especially for the iOS Linux instance, we then can face a wide palette of options that we can use to utilize antFarm's scalability and improve its performance to see the numbers we want to see, and to see the performance of the antFarm that we will be satisfied with. For example, this is an interesting fact. We saw antFarm running on a Graviton-powered AWS instance, and we were actually glad to see that performance actually did improve. The improvement was about 30 to 40% on the load speed. Regarding the Queen API, it can be set on Snowflake, MS SQL, or PostgreSQL. And one Queen API can facilitate multiple different antFarm instances. So, for example, once we have built this one Queen API, and we want to test the performance of I don't know AWS instance, all we need to do is to create these different AWS instances and connect to the same Queen API, and then run tests and compare the numbers. Next to all that, antFarm also provides the possibility to set it up on the local machine that has an NFS or SMB mount, and we can use it for a fast data extract from a database. For example, that is possible on Netezza. With Netezza, we can connect to the database, and with the SQL commands, we create an external table that can be seen with antFarm, and with that, we can export data in a CSV format with great speeds. To talk here a bit more, on the other hand, the shared folders capability is similar on the S3 or Azure, and can be used to import the data via external tables to Netezza or Oracle, since both are capable of reading external tables in CSV format. Moving on. For the end, I want to present you how can antFarm actually help you. As Miha mentioned, if you have data on all the supported data, all the supported databases that support Python DB API 2.0, we can help you export that data in a CSV format and transfer the data then to the desired destination quickly and efficiently. Exported files can even be copied to Azure, block storage, or S3 after they were exported, as I mentioned before. And additionally to that, if destination can bulk load data with SQL, antFarm can help automate that process for you. And after everything is transferred and loaded, antFarm can, as Miha already mentioned, can execute additional processes, for example, calling some SQL commands or call a procedure on the database. And with this, I would like to thank you for your attention, and we will be delighted to hear any questions from you.
Okay, thank you very much. Let me check if you actually have any questions. No, currently we don't have any questions. So with this, we're gonna wrap up today's presentation. Thank you everyone for joining in. Of course, if you have any questions, please do not hesitate to contact us either through sales, general email, or directly to my email, clement.logar@insight.com. With this, I'd like to thank you very much for participating in this webinar, and have a nice day.